So welcome to the next module for our SQL Select. What we'll be looking at today is where the important stuff begins to come together. And that is we'll be starting with two tables and then joining multiple tables together. The importance of this is that Alteryx has its join. Its join is slightly different than the database join, which actually makes it much more efficient since it never removes any data. It simply separates the data into three parts: left, inner, and right. The SQL join, however, you got to tell it which of those pieces you want to see. But why this is important for your Alteryx workflows is that if you're dealing with the average size data warehouse, you have tens or hundreds of millions of records in a lot of your tables, especially transaction tables. And if you want to separate out just the data that you need from that large data set, Alteryx is not the place to do it because you have to bring all that data into your workflow, and that can take quite a bit of time. So what you want to do is get comfortable with using table joins in order to reduce the amount of data that you will be bringing into your workflow, and then utilizing that select statement that you've developed and tested through your SQL desktop tool in order to limit the amount of data that's coming into your input widget and into your workflow, and then do the additional manipulations of your data along the way. The SQL select statement is very powerful. A lot of that power we will not be talking about because it makes sense to utilize Alteryx to do that kind of processing. It means you only have to learn to use one language. It's a much simpler language to learn to use. It's also more powerful, a lot more flexible and feature enriched. So let's look at just the basic joining of tables. And in this little module, what we're going to be talking about first is simply joining two tables so we can understand left and right outer joins as well as the inner join, understand the syntax and the methodology by which you would type that in and execute it. We're going to spend a little bit of time talking about data models, either from a physical data model that I've created for these tables that we'll be using, or looking into the RDBMS structures to understand the relationship between tables, because that is how you have to join your data together in order to create either a reduced set of data or a more enriched set of data. We'll then look at how multiple table joins can be built, as well as some of the dangers in the multi-table joins. And finally, just as a sort of extra, we will go ahead and embed a SQL select statement into an Alteryx input widget. And rather than just use the input widget, which is pretty straightforward, we're going to use the dynamic input widget because that gives you some more flexibility, and I just want to expand your horizons a little bit. So let's take a look at it. Where do you start with this select statement? Obviously, you start with your desktop tool. So we're using MySQL, so therefore that is MySQL Workbench. I've connected this to my Amazon Web Services database, and from this we can begin to execute some queries. And how you want to start is simply the very simple query to start with, which in this case would be, say, a select star from, and we'll be working first with our puppy dimension. Type it in, pause for a minute, it brings up the list. I can click on the puppy dimension here, and this will run. Don't forget about our aliases. Aliases are extremely important when dealing with table joins because you have multiple tables. You want to make sure that you identify each of the tables as an alias so that you know where the attributes are coming from and don't create any confusion for the reader or for the SQL interpreter. In this case, I always like to use 2 digits if practical. It alleviates the problem of overlapping, hitting into reserved words. I really refrain from using ABC just as generic identifiers. I try to make them say something. So PD in this case is very easy for me to reference puppy data or puppy dim. We can execute this just to show how it will work. You'll see it returns the data for us. But what we're really more interested in is going ahead and joining this data. So we're going to use the join command, or in this case we'll be using an inner join. As you can see, it turns blue. Those are all reserved words, so you know we've typed it in right. We want to join this puppy dimension to its puppy fact table, which is located here, just in case you just don't like typing things in. We also happen to have puppy fact here, so we can drag and drop from here into there. Your choice. You can also just type it in. It's pretty simple. We'll give it an alias of PF for puppy fact. Now we must denote to the circle interpreter how it is that we want to put these two records worth of data together. So we use the on reserved word that indicates that we'll be creating basically a where clause with a couple of predicates if we need more than one. In this case, we only need one. What we want to join is for the puppy fact table, we want to join it according to the puppy WID, which is the generated warehouse ID for this record. And that's going to equal the puppy dimension. And then keep in mind, dimensions just have a WID in them. So there's our WID for that. It will join these two tables. We want to denote what columns we want. So let's go ahead and puppy fact, add the puppy WID. Getting it to help me fill in. I want from the puppy dimension, I need puppy name. And it'd be nice to have the puppy birth date. And finally, from the fact table, we want the birth weight in ounces. This is what's known as a one-to-one join. I know that just simply from understanding the data set. What that means from a one-to-one join is that there is one record in puppy dimension that matches one record in the puppy fact table. You can now execute that query. It runs quite well. It shows us the puppy WID, the puppy name, puppy birth date, and then its weight, showing that we've combined those records together. Things look good. Let's take a quick look at what we mean by this one-to-one, and then we'll also be jumping into a one-to-many. But right now for the one-to-one, let's go back to our presentation. And this is where nomenclature becomes standard to everybody that uses SQL for a while, but looks a little bit more confusing to you that start with it. And that is when you join two tables together, there is what's considered a left table and a right table. In SQL terminology, or in the structure of the SQL statement, the left table happens to be the one that is first in the list, and the right table is the one that is second in the list. So in this case, we had our first table being the puppy dimension, and then we joined with the right table then being the puppy fact. So for example, one-to-one join, what we're talking about is on the left, I have these 5 different names that are all ID'd 1 through 5. I have 5 colors, which are ID'd 1, 3, 5, 7, and 9. When I do a one-to-one join, in the inner join for the one-to-one join, which is what we did, we want to see the intersection of these two sets of data. In that case, the intersection happens to be these 3 records. For ID 1, we have Bill Blue. For 3, we have Dave Green, and for 5, we have Vera Yellow. You notice that the other mismatched records are not brought out. In other words, Bob and Sally don't have a match in color, so they are not put into this solution set. We also want to talk very quickly about the one-to-many. That is where when we query on the left, we will find multiple records to match it with rather than just one record. In this case, we're going to go ahead and change this. This is sort of the hard way of doing this. We could just always start all over again. No reason not to show that, which will be a select star. In this case, we're going to do the breed dimension. Again, we can type it in, or we can just go ahead and copy it through. So we'll go ahead and drag, in this case, breed dimension. Drag the wrong thing in. That's all right. Let's call that BD. And we want to go ahead and join it to the puppy table. In this case, the puppy fact, because after all, we're dealing with a data warehouse data mart. PF. You notice I left off the word inner. The word inner is optional. If you don't have anything before the join, it assumes that you mean an inner join. I would imagine 95% of the queries that are written and or viewed or generated will not have the inner. So when you see just the word join, you have to think inner join. No one wants to type more than they have to. In this case, if you remember our data, what we have for the breed dimension happens to be a breed warehouse ID. So that's in puppy fact as breed wid. Just so you can see, you can put these in any order that you like. Order does not matter in that clause. So we can start out with the wid here and join it to the puppy breed wid. Want to limit the data coming out so you can see it. We can have our where clause. In this case, we only want to see where the wid is equal to 4, just as a choice of one of the many breeds that are in there. What do we want to see in our output? I put the star in there just as a placeholder so that the query could go ahead and help fill things in for me. It's your choice how you do this. Let's look at breed name, and let's go ahead and look at the fact table of birth weight, just in case we want to know how much these different puppies weighed when they were born. Now I know that when I have a breed, there are multiple puppies that have that breed, so this will generate a one-to-many solution set. And you can see down here that that is indeed what happened. So we chose breed 4, which is the Corgi, and then there are all of the pups and their weights for that breed. So this is how one way I can then reduce out by a specific breed to get the facts that I need from there. Taking a look at what that says from our Venn diagram. Our one-to-many join is, in this case, we still have our same names, but now we have events for those names. Event for ID 2 happens to be sleep. 4 has 2, which is dance and wake. So we can see again, since this is an inner join, we want to see the intersection. But in this case, when we join them together, Bob only slept, whereas Sally danced and woke. As you can, that means that we joined record for Sally to its 2 events over here, giving us a total of 3 records. The rest of the left and the right side were ignored. So let's talk about that outer join as opposed to the inner join by again going to an example. So let's start again with a query. In this case, this example, we want to go ahead and join our puppy dimension again, but this time to the costume table. So here's my puppy dimension. Call that PD. And now we want to do, let's go ahead and just do our regular join just to show you the results. And it's puppy costume fact. We'll call that CF just to keep things organized. How do we want to join that? Well, we want to join that on my puppy dimensions wid is equal to the costume fact tables puppy wid. And now I'll just go ahead and we want to return some of the data set just to make this simple. Let's go ahead with puppy wid, puppy name, just to keep things going to see which puppy that happens to be. Let's go put their birth date in here as well. And finally, out of the fact table, let's look at the fact in here, which is sizes count. And if you like to know what that looks like, go ahead and let's add the text associated with that as well. So when I execute this, you see I have my puppies information as well as the sizes and the count of the text for those sizes. But you'll notice that for puppy 2, we go ahead and we can see that puppy 1 does not exist, neither does puppy 5. They're left off because not every puppy has a costume. So if I want to indeed see every puppy in this list, where they have a costume or not, that's when I need to do a left outer join, which this says is my first table's puppy. That's the left side of the join, and custom fact is the right hand side of it, and we want to go ahead and return the entire left side as an outer join to see all of the puppy information. We execute this, and you can see that for puppy 1 it had no puppy costume fact, so the attributes from costume fact were indeed sent back as nulls. This is where nulls come into your data set and need to be handled with. I really want to see that puppy width, so I cannot get it from the costume fact table, which means that I want to go ahead and get it from the puppy dimension. So I can modify this to get the width, and I'm going to go ahead and leave that alias there because I really like seeing puppy width in my output opposed to just width because it's not very informative. I execute this, and you can see now the puppy width is filled, but the customer fact columns are not filled. In case you're wondering about what these queries look like, you may have never seen the word outer, because the word outer is assumed. Once you have a left in front of the join, it assumes you mean an outer join. So most people, or just about everybody, leaves the word outer of this, but you have to think that when you see left or right, it is an outer join. If you see nothing, it's an inter join. You have to begin to read that way. We'll execute this so you can see that the same information is returned. So let's look at our Venn diagram. For the left outer join, what that says is if we go back to our first query, we want to see all of the names and only a color if one is associated. And that means that we want to see this entire left side. So I've moved my result set over here to indicate that my entire left side is going to be returned. And anywhere that it finds a matching right side piece of data, it'll go ahead and match them up. So now Bill, Dave, and Bears all have their colors, but Bob and Sally, who were left out on our inner join, are now returned with no value in an event, which is essentially a null. We'll take just a moment to talk about the right outer join, which in that case will want to return everything from the right hand side. Most people very infrequently use a right outer join. I myself have remembered using it a couple of times over the past 20-some years that I've been running queries to take care of some kind of sticky multi-table join. If I was to do that again, I would actually use a different join construct to try to avoid the sophistication of a right outer join in the middle of other inner joins and left outer joins. But that's for our last subject area that we'll be getting to in another class. But just to show you what we can do with the right is actually just looking at the data in the reverse order, where you start with the what I call the minor table, and then you finish with the major table. If you look at this query we have right here, you can quickly modify this into a right outer join. We'll get rid of the puppy table up there, puppy dimension, and we'll go ahead and move the costume fact up to the first. So now this is the first table, which is the left table. This is the second table, which is right. Even though this is the deriving table that I want to see, I can go ahead and then type right in there. Execute this query now as a right join. So puppy dimension has simply slid to the other side of our Venn diagram. We're going from top to bottom, depending on how you want to look at it. Run my right join. You can see the exact same data set has been returned. So if you want to think right to left, you can do right joins. If you want to think left to right, you will use the left joins. Again, most everybody tends to fall into right joins. So the question is always asked, how do I know how to join two tables together? Well, there's a lot of ways to look, but there is really no answer. One thing that helps is if you have a standard naming convention, so that columns that should join together, have a common name or a very descriptive name that understands commonality. In the data warehouses that I have built, we tend to assign unique IDs to each of the dimension records. We call that the warehouse ID or WID. And then the reference point happens to be in a table that would contain that WID. It has the name of the dimension followed by WID. So for example, in what we've done here is that within the puppy dimension table, there's a WID. And then within any fact table that references back to puppy, it has the column called puppy WID. People see that within your objects and they know how to join it. And it also very much helps if you have documented this and make it available to everyone that's trying to use the data. Second place to look is within a data model. If you have an active data architecture team that is designing a databases for you, either an operational database or a data warehouse, they should have data models that will help you see how tables fit together. This being a very messy picture, we, for example, had our puppy dimin, and we can see that if we track any of the lines, these are considered relational lines. It shows a parent with the slash next to it and the child with what's called the crow's feet down here at the end. So here's our puppy dimension, and it has as a child, for example, the puppy trick integration fact table. We also can see here, just look at very quickly at the puppy fact table where we did our one-to-one join between that dimension. We see that here we have the WID from the puppy table, and here denoting in the data model is an FK next to that column, which says that that column is coming from a reference. Well, we can assume through naming convention that they fit here, or we can click, if we actually have access to the data model, we can click on that. And if we have open here, we see that it tells us information about that foreign key relationship. In this case, the parent table is puppy dimension and the child table is puppy fact. So that is how we can find out how to join tables looking through a data model if one has been generated for you. A lot of cases you do not have that either. So then you need to turn into the database itself. And so, not for this example, but I went ahead and you can establish relationship definitions within the database. These constraints, as they are called, help maintain the relationship of that data within the data warehouse or the database, whether it be operational or data warehouse. However, a lot of times these are not generated either because they're an afterthought and so you cannot actually look in here and see them. Second of all, in a lot of data warehouses, the maintenance of the data within the tables in association, especially at load time for the relationships, takes too much overhead, so they are left out. Oracle also gives you the ability to define the relationships but not to enforce them, so then they become a documentation point, which I find to be extremely useful. So if you look at the puppy fact table, which is where I did create a foreign key constraint, we can expand out foreign keys and you can see that it went ahead and within the definition of this table showed me this foreign key. So it has in here in this information from the navigator related table is puppy dim is the parent, and it goes from the puppy WID inside of the puppy fact table and goes to the WID. So you can find foreign keys if they've been instantiated inside of the database in your navigator as well. They're not always there. That's where Alteryx can come in, so you can look at columns and see how well the attributes match up by doing some of your profiling through the browse or through the profile widget. So let's look at the basic multi-table join. That's where we'll be joining to more than two tables. The typical place that you would begin to utilize this would be from within your data mart. So here I have my costume data mart. If you notice, we have the customer invoice fact table here in the middle, and it is surrounded by its dimensions. What we want to do is to query this fact table. So we do some analysis of the data, and then we will join it to its dimensions so that we can get dimensional information associated with this data as well. So the recommendation is always that you start simple. And let's go ahead and select and make this bigger so you can see it. And we'll do this select from in order to get this to build for us. We'll start with our puppy costume invoice fact. We'll put it in here. We'll call this CIF just for the better way of identifying it. Typically, you can also just simply reference it as F if it's your center of your fact tables. Either one makes sense. And in this table, we happen to have our bill amount as our primary fact. So we can simply run that query, making sure there's no errors in it. Very simple, very basic. We see what's there, so then we begin to join our dimensions. So if we start in one point or another, let's go ahead and start with our puppy dimension. Call that PD. Identify how we join it. It joins to our fact table, which is F, using the puppy width. And if we slowly add this, we slowly increase our testing. What we want to get out of the puppy width happen to be, let's look at the puppy name. And why not also include the puppy birth date? I'm going to put a comment on this so the query works properly. Execute that. We can see that we're beginning to flesh this out longer. We then will simply join to our next table. Going around that model, we'll look at costume dimension. Joining that on. As you can see, this becomes very routine. Because we feel very lucky, let's go ahead and join this as well to our supplier. Using the width to point to the fact table's supplier width. Once we have this information here, let's go ahead and include some of this as well, which we want to have our costume name and our supplier name. Before we add date, we'll execute it one more time. Looking good. And then finally, we'll join our date dimension. Equals our fact table's date width. It must be build date, so it's a little bit better description. And what we'll want in here as well is the date dimensions. Year, month, number. Do some month analysis. And it might also be helpful if we actually had the day of the month. It's good information. Query that. We see we have all this data represented here. We want to limit the amount of data that we see in order to reduce down the data set, because we just want to look at 1 month at a time. We can then type in our where clause. Our year, month, number. And we've been working with 2021-09. We execute that. And we can see that we have our information reduced down, and our billing amount, which is our fact, is surrounded by all the information from our dimensions, so that we can then do some analysis, summarizations, or other graphical solutions. Straightforward. Data warehousing built well means that you can just do simple joins. Because you have no null values associated, every dimension is resolved. And this data can now then be downloaded or read into our Alteryx workflow or some other analysis. So staying within a single fact table in a data mart is simple, which is why data marts typically are the preferred solution to present to business analysts in a mature data warehouse. It also showed us how to join tables in the easiest manner. But looking at something a little bit more difficult, as well as something that you would do within a data mart, is if we want to get information from both of these fact tables. So the premise here is that we want to go ahead and find out what it is costing us to maintain the costumes for the puppies, ostensibly on a month-over-month manner. But to do that, we want to get the puppy costume fact table, and we want to get it into the query with the customer invoice fact. So we'll start out with this more simply to query the puppy costume fact table with its dimensions. And that is this query, which I've already pre-created. It goes ahead and starts with the puppy costume fact table as our fact, as the dimension, the costume, and the kennel, because that's the information that we need to utilize in order to determine our costing. Executing this returns a straightforward data set. And we'll focus to a degree right here on Robert at the top, which has a number of costumes. So if we go ahead and bring in the costume invoice fact table, we'll need to join it on two attributes, both through the puppy table and through the costume table as well. And we'll add to this what we want out of the costume invoice fact table is the bill amount. From a fact standpoint, but from a dimension standpoint, we will also want to see the billing date width, just so we can understand if we're in the right area. So we run this query, joining down the table, and you see that for our Robert puppy, we've lost a couple of different of his attributes or records. And that is because not every one of Robert's costumes incurred a bill. We fix this quickly with the left join. Execute it again. And you can see that so his baby Yoda costume was one of those that did not have a bill associated with it. And since we want to also see total costing for costumes, understanding where we didn't have any cost is very important to us. So this is where we've now gone, joining from one dimension to another, and then bringing in another fact table with the left join so we don't lose information to begin with. If we wish to know what date these occurred in, then we'll also need to bring in the date dimension. So if we join the date dimension, to this as well and return us the data rather than the billing date. Let's go ahead and work with our year-month number that we've been using in previous examples of this data. Execute this query, and we can see that once again the Baby Yoda costume has fallen off, because even though we've allocated or asked for the left join within the puppy invoice fact table, now joining it to the date dimension, for those records that did not have a date, they're left out of our return set as well. So now that you begin to mix and match your inner and outer joins, you must be careful to understand what the relationships between the different elements in your query are. One thought is simply to make this a left join, and we can see that Baby Yoda came back, but there's no year-month number associated with that. So if we want to see simply 1 month's worth of data, and we add a where clause in here, where our year-month number, going back to what we've been working on, is 2019, 2021, 09. We again still lose our Baby Yoda and any of the other costumes belonging to Robert that do not have a billable in that month. There are a number of ways that you can solve this problem, but for this part of the class, we just want to introduce the problem, make you understand where we're going, and in the final part of this class, we will talk about ways to deal with these more extensive problems in joining multiple tables. But at this point, we'll leave this as a thought process. If you really have this problem right now and can't wait for another couple of segments, please subscribe, drop me a comment, and we can do some discussions through other examples. So let's take a step into the Alteryx world and talk about how I would use these queries that were successful in my Alteryx workflows. So if we go ahead and look at what is a sort of a complex query, which is where we have joined multiple tables together, and we went ahead and limited to just 1 year or 1 month. We looked at 09 for our result set. Let's get this typed in there properly. Just as a reminder, we had this query. This reduced our data set down to the amount of records that we wanted to see to do 1 month's worth of reporting or analysis. And this is, again, more work we need to do. We might do some summarization, some other table lookups, and some other processing to get this done just right, taking care of credits, etc. So what we would want to do is to take this query and embed it in an Alteryx workflow. As I go ahead and bring up my empty Alteryx window, typically what I would want to do with this is just to repeat some of the simple things, bring in my input data, connect to my database. In a SQL editor, I would just paste my query that I was developing within my works session. I would test this query to make sure it's accurate. It's a good query. Just for sake of making this very simple, put a browse onto the end of it. So we run this with the embedded SQL. It executes and does all that work, brings all those tables together for me automatically. Look at the output and look at year month. We just have simply 1 record in our year month. So this is what is considered heavy lifting. But to have a little bit more fun with this, because quite frankly that's boring, let's go over here into the developer widgets, and we have what's called the dynamic input. We're going to drop this into the middle, because what this does is this is going to allow us to, on the fly within the workflow, modify that query, but it bases that query on a standard input widget, which we create as a template within the edit. So clicking on the edit brings this up to this normal window that you're used to seeing. We click on our database. If it's in the SQL editor, we go ahead and put this query in. We also want to do one more thing, which is to make sure that this query is indeed processing the data that I want it to. So we're going to change that 09 to a 00. Test that query. Syntactically, it is correct, but if I actually ran it, it would return me no data because that's not a valid year month. But that's okay, because what I'll be doing is modifying this, doing a few tricky little steps to begin with. So if I always want to run this widget or run this workflow, I want to run it for the previous month. Don't want to have to change that query all the time. And I'm simply going to cut and paste something in here that I put together already. So I want to give it last month's year and month every time I run it, but I don't want to have to do it myself. So what I do here is in the date time now, take it in the format of year, month, day. That allows me to change it from a string to a date. And then I can go into that year or month, go into that date, extract out the year, append it with the month. So this is actually doing math of 100 times year plus the month to give me that year month format. And I do it for the previous month by putting that inside of a date time add. So I take away 1 month from the current date. It is the best way of doing this, so that if you're trying to do this math yourself without the functions, you have to worry about year wrapping. So if you take one off of January, you have to go back. You could do it, but it's much easier just to go ahead and let Alteryx handle that. So we take and we subtract 1 from the current date and create the year month. So as not to actually plug it in there, we want to go ahead and delete the connection, run this just to verify that we get out of it what we expect it to. And we can see that our result set happens to be 2021-09. So that is last month for when this is being run, since this is October. So now we hook these two up. We have that year month that we want to use in our dynamic widget. We have a good query, but if you remember, our query has in it 2021-00. We want to put the previous month in there. So what we want to do is modify that SQL that we've embedded in this template. And we want to go ahead and add, replacing a specific string. This will bring us up the query that we had in there. And if we simply delete everything but that date, so that's the bad date, and we want to replace that bad date with our last year month. So within that query, it sees this text, we replace it with the last year month, so it'll run for the previous month. I can click OK there, put a browse on the end of it. Go ahead and run this. So let's go ahead and run that query, and it again will just return the September data to us. So now we can actually have the rest of this workflow that we'd want to modify to process just last month's worth of data. Every time I run it, it will be moving forward in time from month to month. So this makes it so that it becomes more executable as a production environment, as well as it's doing the heavy lifting on the database, so it will return rather than hundreds of records, which is in my case actually was somewhere in the neighborhood of 5,000 records, which is not very big, but if I had a couple million, it would reduce this down to just 1 month's worth of data for each individual workflow, making it much more efficient. So that's why we're talking about the SQL statement. That's the end of this lesson. Please subscribe, post any comments, send me any questions, and I'm going to be working on the next step in this process. Thank you.